So anyone who's ever messed with a microcontroller could tell you that one of the best places to start off is by looking at some of the most basic example code, which does seem kind of obvious.
So based on your experience, where do you think someone starting off with a microcontroller should start?
In my experience, I would recommend getting your hands on the sample code provided by the software. Once you have that, you can tinker with the values, and then seeing the reactions of those values, you can learn the processes that that code has to offer.
So where would you say the best place to start off is?
I would for sure say that the best place to start is by looking at example code.
For example, one of my favorite example sketches is the Blink sketch in the Arduino IDE, because over the years I've referred back to it time and time again for some basic reminders on how basic parts of code work. And also, the Blink sketch is so basic that reading through it is really quick, allowing people who are new to microcontrollers to get a grasp of what they're seeing, and even edit things like the pin number or the delay between the pin going high or low, which helps build an understanding of what they're seeing. And so in this video, I hope to show you a really basic example of how to make an IoT version of this classic Blink sketch, using a website called AppShed. Okay, so first things first, let's just take a quick look at how a microcontroller is actually able to turn on and off an LED. Now, the microcontroller has these things called digital pins, which we can control through code by either setting them to high, which makes the pin output power, which is anywhere from 1 to 3 volts, or low, which stops the pin from outputting power, thus turning off the LED. Some of these microcontrollers actually have a built-in LED that are connected to a default pin. Like for example, the Arduino Uno actually has a built-in LED on pin 13. So for example, if we set pin 13 to high, it'll turn on the LED. Now of course there are lots and lots of IoT boards out there that all have little differences. So for the purpose of this video, we have tested and will be showing it working on some of the most popular boards, such as the Node MCU, Arduino MK, SparkFun A266 Thing, and the Adafruit Feather. However, keep in mind that if you don't have one of these examples will still most probably work, as most IoT microcontrollers using the A266 Wi-Fi chip have very few differences. Okay, so now that we have our board, we need to download the Arduino IDE and install the necessary libraries that allow the IDE to communicate with our IoT device. So to do this, we need to head over to Files and then click on Preferences. In the menu towards the bottom, we should see Additional Boards Manager URLs, followed by a blank space. We're going to need to copy and paste this link, which can be found in the video description, into the blank space and click OK. From here, we need to head to Tool, then Board, and click on Board Manager. In the pop-up window, you should see a search tab. In that search tab, we're going to search for ESP8266 and then click on the option made by the ESP8266 community. And now lastly, we just need to download and install some libraries that allow the AppShed master sketch to communicate with its website. To do this, we navigate to Sketch and then to Include Library, and then lastly we click on Manage Libraries, which again opens up a pop-up window with a search bar. We need to search for Pub Sub Client and install the one by Nick O'Leary, and then go back to the search bar and search for Arest and install the one by Marco Schwartz. Now with all the libraries installed, we can open the AppShed master sketch in the Arduino IDE. We can find the master sketch on the AppShed GitHub page. All links will be in the video description. Now you'll see that the sketch is actually really long, and so we won't really have time to be looking at it in this specific video, but all it's really doing for us right now is allowing us to control the digital pins from the website, which is where we'll be creating our Blink sketch. However, there will be a future video where we explain the sketch in detail. The absolute only thing we need to do in this sketch is to set the desired name and password for the IoT device, which can be done by changing these two values to the name and password you want. Now we can plug our IoT board into our computer and head over to Tools and then navigate to Board. Now we need to find the board we're using. So for example, if you're using the Node MCU, then click on Node MCU, and if you're using the SparkFun A266 Thing, then click on SparkFun A266 Thing. Now once you've selected your correct board, we can navigate to Port and click on the port that your board is on, and then finally we can click the arrow button to upload the code to the board. Now once that's done, it's a good idea to check your Wi-Fi settings to make sure your board is actually showing up. If it is, we can head over to AppShed to start controlling the board. I'm going to start by logging into my account, but if you don't have one, you can register for free by clicking here. Once inside the website, we need to set which pins we want to control before we can start building the app to control it. So we're going to navigate to IoT Builder, and from here we can click on New IoT Project. Now you'll see the default microcontroller is something called the IO. However, it's just here for cosmetic reasons and isn't actually the board we're going to be using. Now, for example, if I set pin 5 as an output for an LED on this board, pin 5 on my board, no matter what it is, will also be an output for an LED. So from here, we just need to give our board a name so we can find it later. I'm just going to call mine IoT Blink. So now with all of that out of the way, we can actually get started with the project. So to save a little time and confusion, we won't be connecting an external LED to the circuit, but rather using the internal LED we spoke about earlier. Now, because every board is different, the internal LED may be controlled by a different pin. For example, the Node MCU has an internal LED on pin 4, but on the Arduino Uno, the internal LED is on pin 13, like we spoke about earlier. So we're just going to run this example using the Node MCU, which has a built-in LED on pin 4. So we start by clicking the LED icon because we want to control an LED. And then we can connect that to pin 4 by clicking on pin 4. And then lastly, we just need to click the big green save button. Then we can just give it a name like LED and click save again. Now, if you're using the SparkFun 8266 thing, put the LED on pin 5, and if you're using the Adafruit Feather, put the LED on pin 0. Now, if you happen to be using a different kind of board, finding out which pin your built-in LED is on is really as easy as googling the board's name followed by built-in LED pin. Now, we could add more LEDs, motors, or even sensors here, but since we only want to control that one built-in LED, we can move on by going back to AppShed's homepage and clicking on App Builder this time, which will take us to the app building side of things. So from here, we can actually start building an app that will let us control our LED from a Wi-Fi enabled device such as a phone or laptop.